Good morning, children. It's Sanjeev Pal from Srimati LPSAVANI VIDHYABHAVAN, your statistic educator, welcoming you all to the class of statistics. Dear children, we are on to our fourth chapter, Measures of Dispersion. In this chapter, what we are going to study, we are going to see the meaning and the features of a dispersion. We are also going to see what are the relative measures of dispersion, what are the absolute measures of dispersion, right? Also, along with that, we'll see what is range, okay, its advantages, disadvantages, sums related to the range, quartile deviation, its meaning, and how to actually calculate the sums related to quartile deviation, and also its advantages and disadvantages, the average deviation, and also say the standard deviation, and also say the combined standard deviation, which is one of the important topics of measures of dispersion, right? So first of all, get on with what do we mean by measure of dispersion. Here children, now we'll see what do we mean by dispersion, or say measure of dispersion. As the definition goes, a measure which shows how far the observations of the data are scattered from the average is termed as dispersion. I repeat, a measure which shows how far the observations of the data are scattered from the measure of basically with the help of 5 examination, say marks such as 48, 46, 50, 62 and 44. Suppose he scores 50%. Now what this dispersion says, or what this dispersion is all about. Dispersion shows that how far all the observations are scattered from the average. Means what? That this he scores 48, 46, 62, 44. How far these observations are from his average score, that is 50. That is what dispersion is all about. So it is a measure that shows that into a given data how all the other observations are actually scattered from the average score. That is what dispersion is all about. Now children, here we shall study the desirable features or the characteristics of measure of dispersion. Desirable characteristics or the features of a dispersion or of dispersion. Now over here we'll see to the first one, what they given. The definition of a measure of dispersion should be clear and unambiguous. That is, you would find that the definition of the dispersion should be clear. Yes children, we have very nicely seen what is the definition of dispersion. That definition shows what is dispersion. It is actually say the measure that shows that how far all the observations are scattered from the average of the given data. So it is very nicely and very clearly understood what do we mean by measure of dispersion and what it shows, and that becomes one of the desirable feature of measure of dispersion. Let us see the second one. As it has been given, it should be simple to understand and easy to compute. Yes children, how the measure of dispersion should be, that you would find it should be understandable, that what is exactly we mean by dispersion, and obviously it should be very easy to calculate. You would find that whatever the dispersions are, we will see further that which dispersions, okay, we are supposed to calculate. Okay, whatever the dispersions that we calculate, it should be very much easy to compute, or it should be very much easy to calculate. Okay, that is also one of the desirable feature of dispersion. Next, the third one, that it should be based on all the observations of the data. Yes children, while you calculate the dispersion, it is really very much necessary that you use all the observations. It shouldn't be like that you are using some of the observations and say the other observations are neglected, right? So while we calculate the dispersion or measure of dispersion, we should be considering all the observations of the data. Then only we can say that it is one of the best features of measure of dispersion, right? We'll see to the fourth one, that it should be suitable for further algebraic and statistical calculations, right? Measure of dispersion should be such that it should be usable by you in your further statistical calculations, that whatever the further statistics that you compute, okay, measure of dispersion should be a part of it. That is how a measure of dispersion should be. Come to the next one, as it has been given that it should be stable measure, in the sense that if different samples of equal size are drawn and measure of dispersion are obtained, the values of these measures should be almost the same for all the samples. Now suppose over here that from a given population, that suppose you are taking different samples from the different regions, and to those samples, and with the help of those samples you are calculating measure of dispersion, right? When we can say that the measure of dispersion is the best one, that when you calculate dispersion from the said samples, okay, of the population, and if these measures they are if almost the same value, then we can say that it is one of the stable measure. Means what? I repeat that if you actually select samples from the different regions of the population, and to those samples if you apply the measure of dispersion, and whatever the measure you get, if those measures of the different samples are almost the same, then we can say that the measure of dispersion is a stable measure. Okay, that is how your characteristic of measure of dispersion should be, right? Come to the last point, that it should not be unduly affected by very small or very large observations of the data. Yes children, you would find that your measure of dispersion should be such that even though into your data, if you have large values or if you have small values, your measure of dispersion shouldn't get affected by those large values or the small values, okay, of your selected data. That is how your measure of dispersion should be. Here now children, we are going to see what are the measures of dispersion, okay, which dispersions, okay, we are going to study into this chapter. Over here we will also study the absolute and the relative measure of dispersion, but those absolute and relative measure I will explain you when we will do the sums, okay, because over there when I will explain you absolute and relative measures, you will be able to understand, okay, these concepts very clearly. Over here we will see what are the measures of dispersion that we are going to study. The first one over here, we are going to talk about range. Range is one of the measures of dispersion, right, and is the basic one. Secondly, we are going to see what do we mean by quartile deviation, right, what do we mean by mean deviation, and then at the last we are also going to see what do we mean by standard deviation, right. So over here we are going to study 4 measures of dispersion along with the combined standard deviation. Here children, as said, we are going to see the first measure of dispersion, that is range. Okay, now here as the definition of the range goes, that the difference between the highest and the lowest observation of the data is called the range, and it is denoted by the symbol capital R, right. Now while we talk about range, children, range is what? That in a given data, what you do, you pick up the highest observation, right, you pick up the lowest observation of the data, then what you do, you are just doing or finding out the difference of both, right. The difference that you get, the value of the difference is regarded as the range of the data. The value of the difference is regarded as the range of the data. I will give you one simple example over here. Now suppose in the class or in your class, okay, the highest mark scored in statistics out of 100 is 100, and the lowest marks scored out of 100 is suppose 2020, right? Now what is the range of the data? What is the highest observation over here? The highest observation is 100. And what is the lowest observation? The lowest observation is 20. Now what is the difference between them? 100 minus 20 gives you 80. So what is the range over here? The range is 80 marks. The range is 80 marks. Why? Because you picked up, say, the highest score, that is 100 marks. You picked up the lowest score, that is 20 marks. You found out the difference between them, right? It gave you what? It gave you the range of the data, that is 80 marks. So over here, what is range? Symbolically, range is actually denoted by capital R, and as it is given over here, the formula XH minus XL, that is, you can say highest observation minus the lowest observation. As XH says, the highest observation, and XL, the lowest observation, right? And over here, as it has been told, that R is what? R is the absolute measure of dispersion. How it is the absolute measure? As you will see to the sums, right? I will explain you. So this is actually is range. Now here shall children will see what do we mean by coefficient of range or relative range, right? As you can see, the coefficient of range is also regarded as relative range. So coefficient of range is equal to capital R upon XH plus XL. Now what do we mean by capital R? Capital R, as we saw previously, that it is actually range. So you can use XH minus XL upon XH plus XL also to find out the relative range or the coefficient of range. Over here, what is your XH? Again, XH is your highest observation, and what do we mean by XL? XL is your lowest observation. Over here, you can find out the relative range or the coefficient of range by two methods or two formulas as given over here, that is R upon XH plus XL, or say XH minus XL upon XH plus XL. Depending upon what is given to you into your sum, you are going to use these values. So that is what relative range is or coefficient of range is. And you will find that while we talk about, say, coefficient of range is your relative measure. Here shall children will see our first example, right? What is been given over here, that is the runs scored by a batsman in his last 10 innings of cricket matches are 48, 75, 37, 52, 93, 81, 25, 72, 18 and 60, 60. Find the range and the coefficient of range of his runs. Children, over here they have told that find out the range and the coefficient of range. So again, first of all, we will concentrate on finding out the range. What we have seen for range, we need to have the highest observation and lowest observation. Why? Because we have seen the formula that while we talk about range, how we find out the range? Range is your highest observation, right, minus lowest observation. That is, your capital R is equal to XH minus XL, right? Now, in the given sum, if you will see what is the highest value, I am repeating all the scores, that is 48, 75, then it is 37, 52, 93, 81, 25, 72, 18 and 60, 60, right? What is the highest value over here? The highest value you would find is 93, and if you see the data, the lowest value is 18, right? So while we talk about range is your XH minus XL, that is actually 93 minus 18 will give you 75. And so what is your range over here? The range is 75 runs. Children, in range you will have its unit, right? As both 93 and 18, okay, its units are mentioned, okay, these are the runs, and that's why as you find out the difference, the 75 that you are getting, it will be with units, that is R is equal to 75 runs. Now children, over here now we shall study why it is called the absolute value or absolute measure. Okay, in the measure where you need to show the units or where you will have units, okay, that particular measure is regarded as, say, the absolute measure. And that's why while we talk about range is what? Range is an absolute term, right? Or it is an absolute measure. Similarly, as we have seen coefficient of range, okay, we have seen the formula, that is coefficient of range is equal to what? Is equal to capital R upon XH plus XL. Capital R we had seen above that it is 75 upon XH, that is 93, plus 18, which is XL, right? As you will solve this data, you would find your answer is 0.6757, but we will have the measure only with 2 decimals, right? So over here your coefficient of range is what? The coefficient of range is 0.68. Children, over here we can't have its unit, okay, we can't have its units, because you will find that in the numerator also runs are there and in the denominator also runs are there. That's why in the final answer you can't have the units over here, which is runs, right? So over here what is our coefficient of range? It is 0.68, and it is actually the relative measure. Now why relative measure? Because over here in relative measure we don't mention the unit. Over here in this particular sum, what is the unit? The unit is runs. But in coefficient of range we can't mention, or we are not mentioning the units, and that's why it is also known as a relative measure. So children, now you understood this sum. Now you understood the concept of what do we mean by absolute measure and what do we mean by relative measure, right? So this is the first example of range, right? The other examples we will see in our next video. So thank you very much.